Hello, everyone. This is Dr. Marrero from Math Topics. If this is your first time on the channel, I hope that you like the video and you subscribe and share. In the description below, we have an interactive link in which you can practice questions like the one that you see on the board right now. Given the function f of x, 3 over 20 x to the fifth power minus x to the fourth power plus 2x plus 2x to the third power, find all x values where f has an inflection point. This is a typical calculus question. When do we have an inflection point and what we need to find it? So we need to find the first derivative of the function and we need to find the second derivative of the function. When we find the second derivative of the function and we notice that the second derivative of the function changed the signs, we have an inflection point. Let's do this simple procedural mathematics in calculus. So we are going to find the first derivative of the function f, which is no more than polynomial function. So very easy because we use the power rule. 5 times 3 over 20. This is the first step. x4. Remember that we subtract 1 to the top, to the exponent. We do the same here. 4x to the third. We subtract 1 and we move the 4 in front. Plus 3 times 2, 6x, and we subtract 1 to 3. 3 minus 1, 2. This is the first derivative. We can simplify this more, but because when we multiply 5 times 320, we can simplify 5 divided by 5 is 1, and 20 divided by 5 is 4, so we have 3 over 4 right here, x to the 4th power. The rest stay the same. And now let's proceed to find the second derivative of the function. We use exactly the same power rules. We move the 4 in front of the 4 multiplying, and the 4 cancel each other out. So we're going to have 3x to the third power because remember in the power rule, we subtract 1 to the exponent. Right here we have negative 12x squared, and right here we have 12x. This is the second derivative. What we do now, okay, we can equal this to 0, the second derivative, right here. 0 equals 3x to the third power minus 12, x to the second power plus 12x. We can factor out 3 here. 3x, we can factor out 3x. So we can say that if we factor 3x, we have here x squared. Negative 12x squared divided by 3x is negative 4x. And 12x divided by 3x is just 4. Okay. So this is very simple. Because these two terms are equal to 0, we have 3x equals 0, x equals 0. It's a possible inflection point. And we have x squared minus 4x plus 4. That is no more than a trinomial. Then you can factor x minus times plus is minus. So a combination of two numbers that when you multiply give you 4, and when you add them up give you 4 positive. Give you negative 4. So it's 2 and 2. So we also have here x minus 2 to the power of 2 equals 0. So we have another possible inflection point here, x equal 2. So we have x equals 0 and x equal 2. So when or where the second derivative changed the sign. So we need to prove it by plugging the values of 0 and 2 into the second derivative and notice if they change the sign. Let's do it now. First, we're going to use the number line right here. And we're going to place 0. We are going to place 2. I'm going to place, I don't know, negative 1 right here. I'm going to place here 1. and I'm going to place here 3. So I have those values. Remember my candidates. My candidates are 0 and 2. I want to see where the second derivative change this sign. If I replace the x by 0, remember what is the second derivative? The second derivative, let me put it over here. The second derivative is 3x times x minus 2 squared. Okay, that's the second derivative. That we equal to 0, and we factor out 3x, and then we factor the trinomial. So this is the second derivative. If you substitute the x by -1, okay, so you have -1 minus 2, -3 to the second power is 9. Okay, these terms here will be positive. So I'm saying that you replace the x by -1 to the left of 0. So we have -3 to the second power 9. And then we replace 3 times -1, which is -3, and -3 times a negative number times a positive number here is negative, the answer. So we have negative on this area. I'm going to evaluate the 1. So 1 minus 2 is -1 to the second power will be positive, and 3 times 1 will be 3, so we have a positive times a positive, so this side here will be positive. All of this side here will be positive. So let me evaluate 3. So we have negative on this side. Let me use my highlighted. So we have negative on this side. We have positive on this side. Okay. So let me use a different color. Positive on this side. Okay. And let's plug in 3. If I plug in 3, this expression here will be positive, 3 minus 2 to the second power. And this expression here also will be positive because 3 times 3 will be 9. So positive times positive, it will be positive. So we have another positive area here. So I can see that the number 2, x equal 2, is not an inflection point because the second derivative is not changing the sign. But I can see that the second derivative is changing from negative right here to positive right here. So 0 is the inflection point. X equals 0 is when or where the location where the second derivative changed the sign. Let me summarize to find the possible values of that f has an inflection point. You find the first derivative of the function, the second derivative of the function equal the second derivative to 0, and then you evaluate the neighbors of those points to see if the secondary, you evaluate the neighbors of those points in the second derivative. If you see that the second derivative changes sign like here at x equals 0, that is an inflection point. I hope you liked the video, and don't forget, subscribe, share, and in the bottom, in the box below, you can find a link to more practice about this. Thank you. See you in the next video.